Assalamu alaikum warahmatullahi wabarakatuh. Welcome back class 7th in your online physics class. Today I am going to start chapter 3 energy. So we all know that when we apply force on an object, when you apply force on any object, what happens? That object moves, and when that object moves, it means that we have done work on that object, right? So, however, work cannot be done without energy. Work can only be done when an object possesses energy. The object that does work spends energy, and the object on which the work is done gains energy. For example, when a girl rides a bicycle to a certain distance, she spends energy in doing work. Similarly, when a boy, while playing football, runs all around the playground, he spends energy in doing work, right? So, in this case, when the girl rides the bicycle to a certain distance, it means she is applying force on the pedals, right? When she applies force on the pedal, it means she transfers her energy to the bicycle. As a result, the bicycle moves and does some work. Does any body that possesses energy can do work? It is clear, right? Then any object that possesses energy can do work. Now, what is energy? Energy is the capacity or ability of doing work. Okay, next topic is work energy relationship. Now, we all know that a body possessing energy is capable of doing work. Now, if a person is hungry, he does not have much energy. When you are hungry, then we will not be able to do work. We feel low. It means that we don't have much energy to do work, right? So if a person is hungry, he does not have much energy, so he cannot do much work. But after taking food, the person gets energy and hence do a lot of work. From this, we can conclude that if a body does not, it cannot do any work. A body possessing greater energy is capable of doing greater work. Whenever a work is done by a body, an equal amount of its energy is used up. Thus, energy and work are correlated. Energy must be supplied to an object so that it can do work. Now, SI unit of energy. Energy is measured in the same unit as work. The SI unit of energy is joule. When an object possesses 1 joule of energy, it means the object has the capacity of doing 1 joule of work. 1 kilojoule is equals to 1000 joule, and another unit of energy is calorie. 1 calorie is equals to 4.186 joule. Now, different forms of energy. We have different forms of energy. Energy exists in different forms. The main form of energy are potential energy, kinetic energy, heat energy, chemical energy, light energy, sound energy, and electrical energy. Now, the potential energy along with kinetic energy is known as mechanical energy. Okay, so we have mechanical energy, heat energy, light energy, sound energy, magnetic energy, electrical energy, and nuclear energy. So, in this chapter, we will be going to study all these types of energies. First is potential energy. The energy possessed by an object due to its position or configuration is called potential energy. It is the work done in the bringing object to that state or position. For example, a compressed spring has potential energy. It is because of its compressed state. When we compress a spring, it means that we do some work on it. So this work is stored in the compressed spring in the form of potential energy. So a compressed spring has a potential energy. Now second is a stretched rubber sling of a catapult has potential energy. This energy does work in restoring the stretched rubber sling to its original position. Water stored in a dam has potential energy. It is because to the work done in storing water at a height in the dam. This energy can be used to do useful work like turning the blade of a turbine to generate electricity. Similarly, the wound-up spring of a watch and a stone placed at a height also have potential energy. Now, potential energy is affected by, first is mass of the object. If the mass of the object is greater, then there will be more potential energy stored in that object. And second factor is height at which the object is placed. If the object is placed at a greater height, it means that it stored the more potential energy in it. So the potential energy factors affecting potential energy of an object placed at a height. Number 1 factor is mass of the object, and number 6 is height at which the object is placed. More mass, more potential energy. Greater height, more potential energy. Next is kinetic energy. Okay students, can you differentiate between a stationary ball and a moving ball? Can you differentiate between a stationary ball and a moving ball? Now see, the object is the same, but the difference is a moving ball possesses kinetic energy. When the ball is at rest, the ball is at rest. When the ball is moving, the ball is moving. So the difference is that the ball is moving. The object is the same. So kinetic energy is the energy in motion. When the ball is moving, it means it possesses kinetic energy. Right? So kinetic energy is the energy in motion. So when you are running or you are walking, it means you have kinetic energy. A moving car has kinetic energy. Now what do you think about the flying bird? Does it have a kinetic energy? Since it is flying, it has kinetic energy, right? But the bird is also at a height, so it got potential energy as well. Thus, the sum of kinetic energy and potential energy is known as mechanical energy. So, mechanical energy is the sum of kinetic energy and potential energy. See, when we raise up a hammer, so the hammer possesses potential energy because because of the energy, because of the position or state, hammer possesses potential energy. Now when falling down, when we fall down the hammer, when falling down the hammer possesses kinetic energy because that is the state of motion. So when the object is in motion, it means it possesses kinetic energy, right? So potential energy is stored energy due to position or state. Okay, student, this is it. You have to read the chapter till here, and we'll do the in the next class we'll discuss other forms of energy.